Right now, we're going to dig into a real planetary mystery. For decades, scientists have been keeping a close watch on our climate, and what they've found recently is, well, it's a strange signal. It's something that just doesn't fit with our planet's long history. So what is going on? Let's get into it.
So that brings us to the big question, right? Why is our planet warming in a way that is so unusual? And it's not just that it's getting hotter, it's the pattern of the warming that as scientists really puzzled. It's like we're putting together a puzzle, and some of the pieces just don't seem to fit.
Okay, so to really wrap our heads around this mystery, we need a baseline. And the most important number to remember is this one, plus 1.2 degrees Celsius. That's how much the world's average temperature has already gone up since we started burning fossil fuels on a massive scale. This number, this is the starting point for our entire investigation.
So, what makes today's warming so strange? Well, to figure that out, we first have to understand what's normal for Earth. Our planet actually has a natural pulse, a kind of heartbeat that's been beating for millions of years. And this rhythm has shaped our climate in very predictable, very long-term ways.
And if you look back through time, you can see this rhythm perfectly. For about 2.5 million years, during what's called the Pleistocene epoch, the Earth was in this constant dance between long ice ages and shorter warm periods. Then, about 12,000 years ago, that changed. We entered the Holocene, a beautifully stable warm period. It's the period that allowed human civilization to flourish. And that brings us, well, right up to today.
So what's the engine behind these huge, planet-altering swings in climate? Turns out it's mostly due to a set of 3 long overlapping orbital patterns. They're called Milankovitch cycles, and you can think of them as the planet's own natural pacemaker, setting the tempo for ice ages and warm spells.
First up, you've got eccentricity. This is all about the shape of Earth's path around the sun. Over a really long 100,000-year cycle, it slowly shifts from being almost a perfect circle to being a little more oval or elliptical. When the orbit is more elliptical, we get a bit closer to the sun at certain times of the year, and that extra bit of energy can help kickstart a warming phase.
Then there's axial tilt. You know how Earth is tilted on its axis. That's what gives us seasons. But that tilt isn't set in stone. Over about 41,000 years, it gently rocks back and forth. Now, a greater tilt means the poles get blasted with more direct sunlight during the summer, which, as you can imagine, leads to a lot more ice melting.
And the last piece of the puzzle is precession. This is a very slow wobble in the Earth's spin, kind of like a spinning top when it starts to lose its speed. This wobble changes the timing of the seasons in relation to our orbit. So these 3 cycles, eccentricity, tilt, and precession, they've been the ones pulling the strings on Earth's climate for a very, very long time.
So for millions of years, these incredibly slow, predictable cycles have been conducting our planet's climate symphony. But just recently, a brand new instrument has jumped on stage and is blasting a note that is loud, sharp, and totally out of key. And this, my friends, is where our mystery really kicks into high gear.
The plot totally thickened back in 2006. After atmospheric methane levels had been pretty stable for a few years, scientists suddenly saw a huge, unexpected spike. And the really alarming part? It hasn't stopped. The levels have just kept climbing year after year.
Now, to get why this is such a massive deal, you have to understand just how powerful methane is. We talk about carbon dioxide all the time, right? Well, think of methane as CO2 on steroids. Over a 20-year time frame, it traps more than 80 times more heat. So even what seems like a small increase in methane can have an absolutely enormous impact on how fast our planet warms up.
Just to put this into perspective for you, methane levels in our atmosphere are now sitting around 1,900 parts per billion. This isn't just a modern record. This is the highest level our planet has seen in at least 800,000 years. That alone tells you that something completely out of the ordinary is happening right now.
So you might be wondering, how in the world do we know what the atmosphere was like 800,000 years ago? Well, the answer is pretty amazing. It's buried deep inside the ancient ice sheets of Antarctica and Greenland. It's basically a time machine, perfectly preserving little snapshots of our planet's distant past.
It's really a fascinating process. Scientific teams drill down, sometimes for miles, and they pull up these long, perfect cylinders of ice called ice cores. Each layer in the core is like a tree ring. It represents a single year's snowfall. And trapped inside those layers are tiny, microscopic bubbles of ancient air. By carefully analyzing the gas in those bubbles, scientists can create a perfect year-by-year record of what our atmosphere used to look like.
And here is the absolute bombshell that came from studying those ice cores. They show a crystal clear pattern. A huge natural spike in methane happens about every 100,000 years or so, and it acts as the starting gun for the end of an ice age. The last time that happened was 12,000 years ago, so we are nowhere near due for the next natural one. This spike we're seeing today, this is something else entirely. It's an anomaly.
Okay, so if this giant methane spike isn't part of the natural cycle, then what's causing it? This is the absolute heart of the mystery. To solve it, we've got to play detective and follow the clues to find the real sources. We can basically split the potential causes into two big buckets. On one side, you have the natural drivers we've already talked about, like those orbital cycles, plus things like volcanoes or natural wetlands. And on the other side, you have what we call anthropogenic drivers. That's just a fancy word for human-caused stuff. Think fossil fuel emissions, agriculture, and landfills. The story of our modern spike is a really complicated mix of both.
And this is where things start to get really, really concerning. The initial warming from human activities is starting to thaw the Arctic permafrost. You can think of the permafrost as a giant freezer packed with ancient, frozen organic material. As it thaws, that stuff starts to rot and decompose, releasing huge amounts of methane. That extra methane then causes more warming, which in turn thaws even more permafrost. You see where this is going? It's a dangerous, self-reinforcing cycle.
So when you look at the evidence for what's causing this recent surge, it's a combination of things. For sure, human activities like agriculture and the fossil fuel industry are major players. Our landfills and waste contribute too. But a big chunk of it is also coming from those natural systems, like thawing permafrost, that have been kicked into overdrive by the warming we started.
So when you put all of these pieces together, a pretty startling picture starts to form. We've essentially pushed our planet's climate system into a completely new state. A state for which there's really no historical roadmap. We're flying blind. And this, right here, is the absolute crux of the issue. The planet is currently releasing greenhouse gases on a scale we normally only see at the end of a major ice age. But we're doing it during an already warm period. There is simply no parallel for this in the 800,000-year ice core record. We are truly in uncharted territory.
And the potential consequences of being in this new climate state are pretty serious. We're not just talking about a slightly warmer future. We're talking about the potential for supercharged, accelerated warming, more chaotic and extreme weather, and massive disruptions to ecosystems all over the world. That strange signal we're seeing in the data today, it's really a warning shot for a much more unpredictable future.
You know, Earth's long history gives us the map. It shows us the rules of the game and how the system is supposed to work. But the data couldn't be clearer. We are now playing an entirely new game, with very different rules and much, much higher stakes. The story of our planet's future isn't written yet. For the first time, we're the ones holding the pen. So the final question is really a simple one. What story are we going to write?